All right. So for number 6 for Kepler's law and gravity questions, in each diagram below, the mass of the star is the same. In which diagram is the force of gravity greatest between the star and the planet shown? All right. Remember, as we've spoken before, when the force of gravity is the greatest, we need a scenario. If we take a look at our notes very quickly, we need a scenario that has the greatest masses, and we need a scenario where the objects are closest to each other. All right, that is what's going to give me the scenario that has the greatest gravitational force between the two objects. All right, so when I see that, I see the greatest masses, right? So the star and planet 2 mass B. So I see a scenario that has the greatest masses, right? So right here, choice 2 and choice 4. Then I also, so that means 1 is crossed out, 3 is crossed out. Then I also need to choose a scenario where the distance is the closest to each other. And when I see that, I can cross out choice 4 because of the fact that choice 2 has the greatest scenario where the masses are at its greatest and the distance is closest to each other. That's why the correct answer is choice 2. All right, number 7. Number 7 says the diagram below represents planets A and B of equal mass revolving around the star. So that, and it says compared to planet A, planet B is what? So one thing automatically we have to keep in mind, even though planet A looks smaller than planet B, it tells us right near that they have the same mass. All right, they have the same mass. So because they have the same mass, that means that the mass factor to find out which has a weaker gravitational attraction, the mass factor does not apply. All right? Only the distance factor applies now. Only the distance factor applies. There we go. Only the distance factor applies now. So compared to planet A, planet B has what? So when I'm looking at the options, okay? When I'm looking at the options, one of the things I realize is that planet B, all right, let me clear this up. Planet B is farther than planet A, right? So if planet B is farther than planet A, right? If planet B is farther, that lets me know, number one, that the gravity between planet B and the sun, or to the star, the gravity is weaker, right? Because planet B is farther. That also lets me know what happens to planets that are further away from a star. Well, if we take a look at our notes, right, we're going to look at Kepler's third law. Kepler's third law. And so therefore it states it right here. Let me see if I can move this stuff away. Hold on, sorry. Let's see if I can just move this side. Sorry about that. So yeah, so Kepler's law says the farther, right, from the sun a planet is, the longer it takes to revolve around the sun. Therefore, it has a longer period of revolution. So the farther you are from the sun, you're going to have a longer period of revolution. You have a longer period of revolution. All right, so when I take a look back, here we go. The option that tells me that the gravity is weaker and a longer period of revolution focusing just on planet B is going to be choice 2. is going to be choice 2. All right, because planet B is farther from the star, which means the gravitational force is weaker, and because it's farther from the sun, it's going to have a longer period of revolution. All right, number 8. Number 8 says, base your answers to the following questions on diagram below, which represents the current locations of 2 planets, A and B, orbiting a star. Letter X indicates the position of the orbit of planet A. Numbers 1 through 4 indicate positions in the orbit of letters B. The question says, if the diagram represents our solar system, right? So number 1, if it represents our solar system, what is the name of this star, everybody? It is the sun, because it represents our solar system. Let's continue. And it says planet B is Venus. So if B is Venus, what planet is represented by planet A? So if planet B is Venus and planet A is closer to the sun, right, than Venus, so I need to know what planet is closer to the sun than Venus. So where can I find that information? Well, I'm going to take a look at my reference tables. And when I take a look at my reference tables, give me 1 second to move this writing stuff out the way. All right. So when I take a look at my reference tables, right, I see Venus is right here. There's only one planet that is closer to the sun than Venus. Right? There's only one planet that's closer to the sun than Venus, and that is Mercury. Mercury is the only planet that is closer to the sun than Venus. So therefore, when I get back to my problem, the correct answer is Mercury. The correct answer is Mercury. All right, so for number 9. Number 9 says that Earth's orbital velocity is slowest on July 5th. So let's take a look. So what do we know? When the Earth's orbital velocity, it's talking about the speed, when it is the slowest, all right, that lets me go to Kepler's second law. All right, Kepler's second law states that the closer you are to the sun, the faster you're going to travel. So the opposite of that rule, right? That rule also goes for if you travel the slowest, where are you going to be from the sun? The farthest from the sun. So if you travel the fastest when you're closest to the sun, then you travel the slowest when you are farthest from the sun. Which option shows that? That talks about the Earth being the farthest from the sun? It is choice 2. Okay? And if we take a look, even in our notes, I'm going to clear this up. So I encourage people to pause. If people need to write things, you know, you have the ability to do that. If I'm talking too fast, you can slow down the play speed as well. But if we take a look at our notes at the same time too, remember that we were talking about perihelion and aphelion, right? We stated that when the Earth is in its July position, it has the greatest distance from the sun. That's why we call this position aphelion, representing the point where Earth is farthest from the sun. If at this point you are farthest from the sun, then Kepler's second law states that you're also going to be the slowest. All right, you're also going to have the slowest speed to go around the sun. All right, so that answer is choice 2. All right, number 10. Number 10 says the diagram below shows a satellite in 4 different positions as it revolves around a planet. Okay, so it says which graph best represents the changes in the satellite's orbital velocity, right, its speed, as it travels around the planet. So remember Kepler's second law, right? Kepler's second law states, if we go back, states it right, let me get it right here. It states that the closer a planet gets to the sun, the faster it travels. The closer a planet gets to the sun, the faster it travels. So just by looking, right, in this case, a satellite is going around a planet, and we said that same rule applies for any object that is orbiting another object. So I already know at location D, it's the closest to whatever it's orbiting, in this case, the planet. Because it's the closest, it travels the fastest. What letter will it travels the slowest? Letter B. Why? Because it's the farthest from the planet. So therefore, that means it will be the slowest. It will be the slowest. Okay? So even without me looking at anything else, I know that at letter D, I need to have the highest velocity, right? And at letter B, I need to have the lowest velocity, all right? Letter C and letter A, they have equal distance from each other. Equal distance. So what does that let me know? That let me know that the speed or the velocity is the same at letter C and at letter A. So I know the velocity for C and A have to be the same because they're equal distance from the sun. All right. Letter D, the velocity has to be the fastest, right? For letter D. And letter B, the velocity has to be the slowest. So when I take a look, right, and remember you could pause this video to remember for the notes because I'm going to clear all this in a second. The only option that shows where D has the fastest, the fastest speed, and where B has the slowest speed is choice 3. Is choice 3, right? No other option has where D is the highest velocity and B is the lowest velocity. And so that's why the correct answer is choice 3. At B, it's the slowest, and at D is the fastest. Why? Because at D is closest to the planet, and at B is furthest from the planet. So that's why the correct answer has to be choice 3. All right, number 11, it says the table below shows the gravitational data for a planet traveling in an elliptical orbit around a star. The table shows the relative gravitational force between the star and this planet at 8 positions in this orbit, letters A through H. Higher numbers indicate stronger gravitational attraction. So that is an important part you even want to highlight right here, right? Higher numbers indicate stronger gravitational attraction. They give us the letters of the planet's position, and they give us the force between the star and the planet, all right? Even before I'm looking at all these letters, there's something I know about the position of a planet and the gravitational force. Remember, the closest you are, the stronger the gravity. Stronger the gravity. All right? The furthest a planet is from a star, the weaker the gravity. So that lets me know when I'm looking at letters A, B, C, D, E, F, G, and H, I'm going to highlight the number that's the strongest, which is 52 at A, and I'm going to highlight the number that's the lowest, which for E will be 10. And if I match up, where is the weakest gravitational force going to be? It's going to be the furthest away from the star. And where is the strongest gravitational force going to be? It's going to be closest to the star. So that lets me know A has to be the closest to the star, and E has to be the furthest from the star. All right. So which option shows that A is the closest to the star and E is the furthest from the star? That's the only thing that matters. And the only choice that shows where A is the closest to the star and E is the furthest from the star is choice 2, right? We see A right here. A is closest to the star and E is furthest from the star. Because E has the strongest gravitational force, A has the strongest gravitational force occurring there, it has to be closest. And because E has the weakest gravitational force, it has to be the furthest. And that's why choice 2 is the correct answer. I know there's a lot of writing on the screen, but I encourage you to rewind and play back so that way you can see what points I was writing, what note. All right, number 12. It says basic answers of question 12 and 13. So on the diagram below. So automatically, we always have this issue from time to time. This diagram right here is focusing on 12 and 13. Okay, on the diagram below, which represents the elliptical orbit of a planet traveling around the star. Points A, B, C, and D are 4 positions in this planet. All right, so let's take a look at 12. As the planet revolves in orbit from position A to D, the orbital velocity will what? So remembers Kepler's second law. What does Kepler's second law says? Kepler's second law, right? To summarize, the closer a planet is to the star. I know my writing is horrible. Closer a planet is to a star, the faster it will travel. The faster it will travel, all right? So what we're going to identify is as it goes from A to D, we're going to see what happens to the distance as it goes from A all the way to D. We're going to see what happens to the distance, all right? So as it goes from A to B, right? So from A to B, now I'm at B, right? First of all, we can say that at A, that's the closest it'll get to the star, correct? That is the closest, right? So that means at A, we know it's traveling already the fastest, okay? So when it gets to B, the distance increased. So that means that because the distance increased, that means that it starts to slow down at B, right? Because it's farther. All right. Then when it travels to C, is the distance even longer compared to B? Yes, it is. So that means that when it's at C, it's now the farthest, which means that it slows down even more. Slows down even more. All right. And let me just hold on. I know I gotta erase some of this stuff. I apologize. Just so I need some space. There we go. All right. And then finally, when it gets to location D again, right? Now the distance starts to decrease, right? From C. So when it went from A to B, it slowed down, right? When it went from B to C, the distance between C and the star is the farthest, so it slows down even more. But when it went to D, the distance started to decrease. So if the distance decreased, that means it started, the speed started to increase. It started to increase. So which answer tells me that as I go from A to B, it slows down. From B to C, it slows down even more. But then from C to D, it starts to increase. The only option that shows that it decreases then increases, is choice 3. Choice 3. And lastly, number 13, the gravitational attraction between the star and the planet will be greatest at position what? Now we're talking about with number 13 now, okay? So the gravitational attraction between the star and the planet will be greatest, all right? I already know, as we reviewed before, when is gravity the greatest? When is that gravitational attraction the greatest, right? The gravitational attraction is greatest when it is the closest, all right, between the planet and the star. So which letter represents the closest position between the planet and the star? Which letter, right? The star is right here. And which letter shows where it is the closest between the planet and the star? It gotta be letter A, because letter A has the closest distance. So because it's the closest distance, that means the gravity is going to be the greatest, which is letter A. That's the rest of this video. Have a blessed day.